Hello everyone. So I'm going to talk about what is the difference between thermal energy and heat. Now, at this point of time, these two terms will be quite familiar to you. You have seen them, and you can even use them interchangeably in the lower set. But basically, the two terms, there is a slight difference. So let's take a look. When we talk about thermal energy, we are actually referring to the internal energy of an object due to its kinetic energy. So what it means is that, let's take a look at the solid. The solid particles are vibrating, and when these solid particles vibrate, they will have kinetic energy. So if you add up all the kinetic energy for all the particles together, we say that that is the thermal energy. And of course, if the particles are at a higher temperature, then the solid will vibrate more vigorously, right? So each solid is going to vibrate more at a higher temperature. So when you add up all the kinetic energy for the particles, you find that it will be larger. So that's why we say that for that same particular substance, when the temperature is higher, the thermal energy increases because the particles actually have a larger movement. The same actually apply to liquid as well, because at higher temperature, the liquid is going to move faster than before. So this thermal energy will also increase. The same for gas. So simply put, let's say for example, this is 30 degrees Celsius, this is 70 degrees Celsius, right? So at a higher temperature, the particles will be moving faster, so it has a higher Ke. So we say that the thermal energy increases. Okay, so so this is what happens. Now, what happens when you put a hot and a cold substance next to one another? So if you look at this particle, if you look at this solid, this is a hot solid, okay, and this is cold. Now if you allow, so in this hot solid the particles are vibrating a lot more, this is less. So I can also say that this has a higher thermal energy. It has got larger amount of thermal energy because the particles have a larger kinetic energy, right? So this one has a lower thermal energy because the particles are moving slower. Okay, so if you allow them to be in contact, can you see now they're touching? Previously they are not touching, right? They're not touching, so now they are actually touching. So when they touch, the solid which is hotter, with a larger amount of kinetic energy, is going to transfer the energy over to the colder substance. So it will cause them to also vibrate a little more vigorously than before. So the the flow of energy from the hot to cold, this flow of energy, this transfer of thermal energy is known as heat. So when we talk about heat, we are not talking about how much thermal energy it has. We are talking about how much thermal energy has been transferred. So for example, just giving numbers. So for example, this one has 1,000 joules of thermal energy. This one has 800 joules. You know, and we find that the energy actually flow. So let's say 100 joules of energy actually flow. So the heat flow is 100 joules. So heat refers to the flow of thermal energy from the hot to the cold, whereas thermal energy refers only to the substance. We add up all the kinetic energy within the substance itself, and this transfer of thermal energy will stop when it reaches thermal equilibrium. That means when the two substances are at the same temperature. Okay, so just another picture to show you hot, cold, right? So if you let them touch, then there will be thermal energy that will be transferred from the hot to the cold. So this energy that is flowing is known as heat, and that's why we call it heat transfer. And just a question to that I thought is quite interesting. Um, does it mean that anything with a high temperature has a higher amount of thermal energy? If I have a spoonful of water, and this spoonful of water is at 100 degrees Celsius, and if I were to compare to a whole swimming pool of water, okay, a large swimming pool, a large pool of water at, let's say, 40 degrees Celsius. Now, which one has a larger thermal energy? Is it the one spoonful of water at 100 degrees Celsius? Or is it the whole swimming pool of water at 40 degrees Celsius? The answer is the swimming pool has higher thermal energy. Remember, we said thermal energy is the sum, that means the total kinetic energy added together. So although this one, if we look at every particle, it has got a larger kinetic energy, but because it's only one spoonful, so there are only very few particles. Whereas for swimming pool, although the kinetic energy for every particle is not a lot, but because there are so many particles, when you add up together, this will be more than this. All right, so it's as you know, it's equivalent to if you have three person and each of them has $100, and then another group, you have, let's say, 1,000 people, 1,000 person, and each of them has only $20. So which group is richer? Well, this one, even though each of them has more money, $100, but because there are only three of them, so the total is 300. This one, although each of them only have $20, but when you have a large number of them, then you actually get $2,000, right? So therefore, the this group I say is richer. So and that's the reason why in the swimming pool the thermal energy is larger. Then in that case, maybe I just bring in temperature. So how does temperature play a part here? You know, how is it related? Temperature basically refers to the kinetic energy of one particle, you know, the average kinetic energy of one particle. So if now I only need to look at one of the particles, and if this particle is having a large kinetic energy, we say it's hotter. So that's why the temperature is higher. So this one, if you look at one of them, the the kinetic energy is not as large. That's why the temperature is lower, right? So I hope that clarifies the difference between thermal energy and heat.